I'm gonna start recording so I don't forget. So there's a couple things I want to do, and I'm not exactly sure which order to do them in, but I know we won't get to both if we try to do both. So, and I'm not sure how much sense it makes. We haven't really tried to do this, but we need to at some point have some assessment about where do we stand, what do we know how to do, and I thought about taking class time to do that. But at the same time, I do have a whole thing I'd like to show you how to do, which is new. But it's hardly worth moving forward if we don't understand what's going on now. So I'm just going to feel it out for a second, and maybe I'll do a little bit of each. So some tasks I imagined that you should be able to do, and you can tell me whether or not it's true that you would be able to do them. Make sure I can find this. All right, well, here's one that I think you should be able to do. And you can tell me if you think you'd be able to do it, which would be to create a patch that displays a window that can fade from black to white over 5 seconds.
Yeah.
Yeah, easy.
How would you do it, just out of curiosity?
Yeah, I think so.
Would have like a changing alpha value.
Matrix.
And then
Load in a
change
Would
that
the
over
alpha
time. I guess
value
I don't know.
work,
I'd have to like Q metro it and like I'm
Just
sorry.
with a line object that goes from certain value to another value for the colors.
Yeah, you'd want to go 255 on all of them to 000 or whichever
All
order.
right.
I remember is black to white or
Yeah.
white to black.
So some matrix send a message that would set all the values to some number. Maybe it's a one plane matrix, right? Would that work?
Yeah,
Yeah.
black and white.
And we just go from 255 to 0, right?
Yep.
Yep.
So we would do that with a line. And so I think that one should be like pretty quick. Like you could do that really quickly. And then I said, well, what would be next would be create a patch that displays a window with a
Just that
5 by
window.
5 checkerboard. And
Yep.
that one's harder.
Yes.
What is
Yeah.
a checkerboard?
So it's like a chessboard or a checkerboard. So black and white.
You can do that with scissors and glue. You
Yeah.
have a video that's black and a video that's white, and
Oh, yeah, I didn't think
Yeah.
about that. That's one
You
way
can
to do it.
also set cell if you really wanted to. I like the scissors method better. But you can set
Scissors
cell
or
easily.
set cell, or you could potentially.
Well, that's an
This
interesting one. I might send this as homework because I can think of 3 or 4 different ways to do it off the top of my head. And I didn't think of the scissors and glue one. I did think of, some Uzis in a nested loop. So an Uzi for the rows and an Uzi for the columns, and then just flipping something back and forth from 0 to 1. And I also thought of a way in jit.gen that you could do it. Okay, and then another one I thought of was, could you create a patch that displays a window? And I spelled window wrong 2 times now. It's widno. Can you display a widno with a 10 by 10 grid of random colors? New random colors should be generated at the click of a button.
Yeah.
How would you do
Yeah.
that?
I feel like you could. It would be similar to the checkerboard method, or you would use Uzis to set random numbers. Like you'd use a random.
I feel like you would use Uzis to go through like. I'm sorry, Tyler. I didn't mean to interrupt you. Were
No,
you
no.
finished? I'm sorry. I feel like you would use Uzis to go like maybe the order. This doesn't necessarily matter. Like you can go in whatever order you want, or it can be a random order, right? Because the idea is like we don't have to. I don't know if we're selecting them randomly, but that wasn't stated. But as long as we get random colors, and we can use something like swatch and just generate random values between 0 and 255, 256. Can't remember off the. I
Right,
think
so
it's 255.
swatch being a certain object that has all the colors in it. And you're right,
Mhm.
generate 256 values, those being
256,
between
thank you.
0 and 255, right? So if we start at
Mhm.
0, we go to 255. Or there's another way to do it that's easier, but maybe I'll make this as homework. Right, so if you think about what random is, it's really noisy, and that's my hint to you.
and noise.
Yeah.
Oh, I see.
So, and then, so that would be on the video side of like, well, that's kind of what we covered video-wise, although we did a lot more than that. But those things are, I think these are the harder sort of fundamental things. And then on the GL side, could you create a patch that uses a render context in a display window and uses jit.gl.mesh to display a plane that is 10 by 10? Maybe, right?
Yeah.
I mean,
Yes.
that's in a patch I passed out, so you could copy and paste, but I wonder off the top of your head, or did I? Off the top of your head if you would know how to do that. So
Yeah.
maybe I'll review that in just a second. And then the second one of those is create a patch that uses a render context and a display window, and using a jit.gl mesh displays a cube that is 10 by 10 by 10. So same sort of idea. So I think what I'll do is I think I'll put these as homework for the week. Those would be the things to do and just sort of see where we're at. Again, you know, what I don't want is I don't want people to feel discouraged that they're making bad grades or something like that, because the material is a little foreign to us and difficult. But I do want to know that we're ready to move forward. I don't want to charge ahead and have people say, I have no idea what's going on. That's a terrible feeling. And I don't want to put anybody in that situation. So I'm totally ready to review if we need to spend some time not moving forward. Because really, in this semester, for whatever reason, we're pretty far ahead of where we usually are. And I think it's because I haven't bothered to spend a lot of time with assessments. Just kind of moving forward. Anyway, with that, what I wanted to do today was to show you how to make shapes without having to define all the points, right? So last time we used the mesh and we were defining points in space that we could string together, and we made a circle, and it was really crazy complex patch. And I'm going to back away from that slightly and show that you can make spheres and cubes and all sorts of things like that without having to define all the points. And so we're going to do that, and I wanted to make something that responded to audio in a way that is not simply just taking the amplitude in, but rather dividing the sound into frequency regions, 4 frequency regions that we'll take amplitudes from. So then we'll have different responses for 4 different spheres for the 4 different frequency regions. And then to make it look cool and sort of move toward, you know, an interesting space, which is sort of the more fun part, we're going to try to imitate what Dan Sandin did with Tom DeFonte, where we'll have the spheres generated digitally, but then we'll take the output of that render space and we'll transform it using video sort of techniques like we learned in the first part of the semester. And we're going to specifically do some feedback and a couple shaders. We won't get to all of that. We'll get to the very basics of that. But to just show you what that might look like, let's see if this will actually work. Let's see, so there's that, and then let's make sure I don't have anything additional open here. Oh, I don't think I do. And one of those. Let me show you what's going on. It's not exactly working like I want it to, but that's typical, right? And I want to share the screen. There we go. And I'll share sound. I'm not going to optimize this. Wow, there's a lot going on here. All right, so I made this patch that I'll put up on the folio thing. And what it does is it responds to sound. But see, we have our 4 spheres here, and they're going to bounce up and down based on the amplitude of 4 different frequency regions, like I said. And then transforming it, let's see what my errors are here. Oh, it can't find the shader that I wanted. So the shaders that I was using aren't there. Okay, well, anyway, what it'll do is it'll feed back. So you see these little ghosts of a sphere there. Well, we could have a whole trail of those going backwards But because my shader's dead, it's not really working. So let me fix that really quick. I'll just bypass a bunch of this. That's too bad. And so there they go, back into space. And then if we were to play some sound, right, this will be jittery for you. But here's the low tone, or the high tone we hear. And then the other tones get picked up here.
I don't hear any tones.
Oh, I know why. I do it every time. In Max, we have to change the driver so that it goes out to zoom. And do this again.
There we go.
And so the balls will move left and right based on what frequency is being detected, and then up and down based on how loud that frequency might be.
What do the ones behind it mean, or are they just...
They are just visual effects.
Repetitions.
So this is the IP, the Sandine Image Processor idea. They just follow what the one in front does.
just delayed?
Yeah, they're fed back. So I'll show you how to do that.
This is amazing.
Anyway, okay, so it definitely has looked better in the past, whatever. There we go. So let's not start here. I won't save that for now. And let's start here with a new patcher. Okay, so we figured out how to make the render space in the video very easily. Is just use the jit.world, and that's what we'll do from now on. And I will call this Spring Mix. And to turn it on, we use a toggle, and we can turn it on. And that's really all you have to do to make this work, right? You can have additional parameters you set, like maybe I want the erase color to be black. So that alpha at the end there. So this is backwards from how video is. Here we have RGBA. Video is ARGB. It's just an OpenGL quirk. And, I could set the frames per second if I wanted to. And it's all just kind of easy to do. And here I'm actually going to do something that we'll use later, which is to output texture. Output matrix. Output texture, both the same thing, I think. I'm going to say output matrix 1.
I have a question, sorry, about the frames per second concept.
Yes.
So we all know that it looks better in 60 frames per second than it does in 30. It just looks smoother. But I've always heard that humans see in 24 frames per second, but I don't think that's right. How is it that we can see discrete?
I don't know the answer to that, but I would imagine that 24 frames per second is not the limit of human resolution. I think for things to become continuous for us, there's a pretty low threshold. But remember also that our drawbang here is going to be rendering things at a certain speed. So I don't know the answer to that question. I'd have to do a little looking into it.
I thought there was something to do with like interpolation with like regard to because I see people post videos that are like 60 frames per second, and then they figure out how to like take older music videos and then interpolate between values. So I think that maybe 24 frames per second is what we can like actually detect maybe, but then like there's also like a factor of like there's this, I don't know, I can't remember. Somebody said something about interpolation at one
I
point.
feel like the interpolation would be adding more frames between existing frames.
Yeah.
Yeah, I guess I don't know the answer.
Eyes don't see in frames, right? So
That's right. They are a continuous medium.
it's different than how cameras and videos work.
Right. I don't know, I guess is the correct answer for me to say. I do know that I have noticed a difference, especially like with computer graphics, for instance. I'm sure if you guys play video games, then you would notice the difference between something running at a high frame rate and a low frame rate. You definitely want to see as many frames as you can. But here I just do 60 because it just seems right. All right, and what's typical here, thanks for the question, Andres. I'm sorry I don't have a better answer.
No, it's okay. Thank you.
Yeah, so I usually, as a standard thing, just go ahead and hook up this send draw. So it sends the bang every time that the render space is drawn. And just looking at these other ones, we've got a dump out, and then over here we've got a texture or matrix output if enabled. So because I enabled this, that means that the world that's rendered will actually come out as a matrix right here. So we could view that in a video plane, for example. But we won't do that right now. And I'm going to turn this on, and now it's rendering the render space. And the first thing we want to do is to make a sphere in the render space. So that is fairly easy with an object called jit.gl.gridShape. So it's a GL object, so it should live in our render space. And it's got lots of attributes, but the important one we want to look at here is the shape can be a sphere. And you can look at the reference or the help file to figure out all the different shapes that a grid shape might be able to be. So we do that, and then it just draws this grid shape immediately. It's a little gigantic for me, so I'm going to scale it down to be 1/10 of that size.
I have a question.
Yes.
Is there an attribute or something that would allow the jit.world video to appear on top like you can with a normal window?
This window here.
Yeah.
Oh, floating, ideally. Floating.
Nice.
Yep. So there's our sphere, and to view it so that right now it looks a little funky, and there's lots of things we can do to this grid shape to make it look a little better. So let's go through a few of those things. One is let's zoom back in a little bit here. So I'll just make a scale message. And here I'm just saying that all 3 dimensions should scale equally. I don't want anything that's not a sphere, I want a sphere. So we'll make it a little bigger here. And so right now we can see that, it's kind of not exactly smooth. It looks very odd, like doesn't really look 3-dimensional somehow. So there's lots of attributes to deal with this. One would be smooth shading. And another might be lighting enable. So right now the lighting does not affect this object, which is why it looks kind of funny.
Could you also increase like maybe the number of vertices? Is that like a value?
Sure. And so the number of vertices is the dimensions of the object. And
I imagine you would want to go too crazy with that, but yeah.
that's correct. Let's see what the dimensions are right now. So we go to the attributes and we would look at dim, and it's 20 by 20 right now. So there are 400 vertices right now. So that's a thing we can change though. We'll just put it there for now. All right, so let's turn on the lighting first. And now it looks like a sphere, right? It's a dramatic difference. Where is this light might be a question for you that you have right now. And right now it just exists in the world. And I'm not going to mess with that right now. If we turn, so it still looks like a hot air balloon, right? We can see these sort of regions where the vertices are and it's drawn. It looks ribbed almost or framed. If we turn on smooth shading, then it interpolates between all those values. And now we don't see the frame as much, right? It smooths that out. Some people enjoy this look, some people like this look. If we change the number of dimensions, then we can make it look really nice. or we can actually figure out what is a sphere if it doesn't have enough dimensions to make a sphere. That looks like that. 7. It takes 7 by 7, makes 49 vertices to get to the center of a sphere. All right, so there we go. These are some basic things, and also sometimes we might want to not view this as a solid object. Sometimes it looks more interesting to use this poly mode, which we looked at before. Yes.
I'm sorry. I'm sorry. This is a little late in the game, but what does the SDraw send to? Where is the receiver of that?
It has no receiver right now, and if I got rid of it, all of this would still work.
Okay.
So what you use this for is anything that needs to output that is not a GL object. So the GL objects, right, have this thing called automatic. If I put it to automatic 0, then it would disappear. So I would have to then send it this drawbang, and then maybe it may be that I actually have to send it the message draw raw. I have to send it some message. I can't remember which message because I don't usually do this. But you can, with the GL object, tell it to draw on its own. Or not on its own, but only when you tell it. But normally we tell it, right? So, so to answer your question, we would send something like the draw. We would receive that at something like a jit.matrix, right? Because a jit.matrix does not automatically output. It has to be told to. So anything on the CPU generally gets this draw to synchronize with the render space. Anything that's a GL object typically would not get this draw message. I have it there as a placeholder for now. Nothing is getting that.
Thank you.
That message.
I was just wondering if it's like a special case or.
It's a good question. I just put it there because I know at some point I'll need it. I always do. All right, so here's our poly mode, and what this does basically, without getting technical about it, is that it allows me to choose between 3 different modes, and here I'm just going to make everything the same. So number 1 would draw the lines, number 2 would draw points, but you can't really see them. Let me increase the point size here. That's a really big point size. So there's all the points. Still with lighting enabled, right? There's the points. And here's with the lines. So Death Star, right? Looks like this with lighting enabled. Smooth shading won't have an effect here. So let's leave it like this for now. Other thing, well, let's take it back to this. So another thing we can do is we can color this object. So, whoops. So color, and remember now we're RGBA. So let's make it red. So there's a red sphere. We do have this alpha value. And let's see if it works. So if I should be able to, well, let's turn on lighting again. There we go. I should be able to make this fade into the background. But we can see that if I do that now, it doesn't really work, because we would have to turn on blend enable, which would allow it to blend into the background. So let's turn that on. And there, it's almost gone. Let's bring it back there. So now it's a kind of see-through, right? It's actually blending into the background. For now, I'm going to leave blend enable off, so I'm not actually going to do that. And one final thing you'll see sometimes is depth enable. which would enable, so it tries to figure out where it's supposed to be depth-wise, so to draw other things that look like it's in front of it. It's just really, there is no in front of it, actually. You know, it's just drawn on top of. So even though this space is emulating 3D space, and we would say something's in front of something else, it isn't necessarily drawn that way unless we tell a computer to do that. So a little more complicated is the depth enable thing. For now, we'll just leave it at default. Okay, so that is grid shape. There's probably more than that, but for now, I think it's fine. And I'm going to change this poly mode to 1, and we see that the lines are now red.
I have a question.
Mm-hmm.
So, whenever I mess with mine, on the dimension, you may have said something about this, but whenever I change the dimension on mine, or maybe I just have it in wrong. Let me check. It makes me have to go back and reset everything.
Oh, you shouldn't have to do that. Well,
Okay.
maybe
I see
that's
what-
not true, actually.
I think I see what the problem is, maybe.
Okay, so
you're right.
there's one more thing. There's one more thing that's pretty important. So I'm going to reduce the scale of this back down some. And the other thing we could do is position this object. So let's position it on the X and the Y. I'll do it like, well, yeah, I'll do it like this. And we'll leave it at 0 on the Z. So that means that it's not toward us or away from us. It's hard to draw that with a mouse or anything else. It moves, it's going to be left on the x-axis or right, and then up and down. Now, kind of an interesting question is, you know, depending on what the ratio is and whatever camera it is looking at this and what the view angle of the camera is, we really don't know for a space that's 16 by 9 how wide this is. Like, what are the numbers, or what are the numbers up and down? So, you know, all the way to the left is what number? You know, we could say -1, but that's actually not correct at all times, and kind of a conundrum. But for now, we'll just feel it out. I hope that makes sense.
I have a question.
Yes.
In the previous ones that you made, you could grab like a gizmo in the video or in the window and drag it around.
That's called the jit.gl.handle.
Okay.
And I will put it in our render space because I don't think you have to do that, but in this case I do. And you connect that to whatever you want to deal with.
Okay.
And, you know, you can do things like move it back and forward, and then, you know,
How do you do
translate
that?
it right and left and all around.
How do you do the zoom?
Don't remember. I'm holding down Option to move this.
So on Windows,
Oh,
it
it's
should be Alt. Yeah.
Yeah.
I think I wrote that down somewhere.
And then we rotate with the mouse, and no buttons held down. Command for me, probably Control for Windows, translates.
Yep.
And then Option moves it on the Z-axis.
Shift is the y-axis.
Yeah. So okay, but I'm going to reset that. And it's kind of interesting to think, well, what's really happening there? So let's take a look. You know, what is it sending? What is it sending out? And there you see it's sending the message position. And if I do this, it's sending the message rotate. So those are some hints to us.
How do you reset it back to?
I'll reset message. There we go. Okay, so I'm going to put this over here. Side note. All right, so we can position things exactly, though, if we choose to. So we'll use this position message. And since I'm sending a list to it, I'll make a message. So let's put it kind of over to the left. And we'll put it down just a little bit on the Y. And we'll leave it, well, I don't think I have it on the Z. So just moving it to the left and down a little bit. Sorry, this screen is so gigantic. So there we go, we positioned it there. And if I go full screen, see how far left it is right now on this small screen? If I go full screen, we see that it's not quite as far left, right? Because the shape of the screen changed. So that's something you'll have to
Alright.
deal with. And it can be frustrating sometimes, but it's good to set your screen in such a way where at least you get close to looking like it will full screen. Okay, anyway. So we've got one of those. We have everything we need for that. Let's make a second one. And let me state beforehand that the way I'm about to do this leads to a better way to do it, as is typical, right? But for now, I just need 4 of these, so I'm just going to copy this information 4 times. I'm just going to do it once for now. So we just copy all of this. And there's our other space out there, our other sphere. Turn its poly mode to 1. And we'll change its zoom to be, or its scaling to be 0.2, looks like we had it at. And position it, and color it, change its dimensions to 30. We'll just make it exactly the same as the other one. But we don't want to position it in the same place, so maybe we want to put this one at negative 0.25. Let's say, yeah, negative 0.33. So we'll put it over there. And now we can change each one of these independently, right? And to just keep going with this, we'll do the same thing. Copy and pasting.
Is there a way to like create a list to do this, so you don't have to copy and paste like the whole thing every time, or is it? It's like
Well, you know, I was looking. Normally, you'd be able to say just, you know, for this, you should be able to say transform and change attributes to arguments. But that really wasn't working so great for me. We can see what happens. Yeah, so it looks like it took a lot of the stuff there that we need. Right, and then it's all just kind of defaulted
right.
to what we wanted.
Okay.
But anyway, I don't mind working a little bit this way.
Okay.
So 1, and then
we
we
need something projector.
30 color, and then we position this at 0.3 and down a little bit. So now it's going to be up here, and change the scale so it's 0.2. And finally, one more time to get the 4th one there. Tedious. And 0.2.
So,
Oh,
sorry, go ahead. Go ahead. Oh,
You're good. Go ahead.
okay. So, something that's kind of been like, as we're making more and more of these and taking up more space, are we still, if we encapsulate some of these things, are they still going to be able to work with the render space? So, like, if yeah? Okay,
Yes.
cool.
So, for instance, I could encapsulate all of these spheres, as a matter of fact. So I could. This is really gross looking. We could just take all of this and say, all right, well, I probably won't need to see much of this, so let's just put that encapsulated there.
Throw them in a poly.
It looks like, oh, shit. Fuck.
The draw.
So anyway, yes, you can do that. It'll draw them. I would have to go through and redo this, it looks like. It looks like it lost a lot of its state doing that because of whatever reason. So it'd be better to do what I did here so that you don't lose the state of all of them. It's a little annoying. It's not a big deal. 1.
Dr. Thompson, my question was, since you're doing this every time, does this become like computationally expensive. Yeah, that's what I was thinking.
It is more, well, it is more computationally expensive to have, well, but it's necessary. If we want to have 4 independent objects that work independently entirely, then this is what we need to do. But really, we don't actually need that, but we'll get to that at a different time.
Okay.
We actually don't need to have each of these be their own independent sphere. We could, for example, just draw the sphere with different qualities, draw the same sphere with different qualities multiple times. And we'll learn how to do that next time. All right, so I hear the birds. Yep. Okay, and one more time. That's a marching band joke. All right, and
Yeah, it is.
30. There we go, and red. All right, we're there again. All right, so the goal was, right, that we wanted to make these bounce up and down based on 4 different frequency regions of a sound. So the 4 different frequency regions of a sound can be attained many different ways. We could bring in a sound and EQ it in such a way with bandpass filters and do it that way. Or we could try to do it with an FFT. I prefer for this particular task to just use a package that allows me to describe audio in various ways without me having to code it all. So there's downsides to this. One is that you can't release a commercial package without paying the author of that. But for our purposes, we can just do it. And if we needed to recode it in some way that's free, we could. So to get a package, you go to the File menu and you show the Package Manager. And there are way too many packages. And the one we care about right now is called ZSA Descriptors. It's right here. And so you would click on it and you would install it. I already have it installed. You can launch it. You can do whatever you want. Let's launch it. And so here we see that there are lots of different things I could use. Fundamental, the spectral flux, these are all descriptions of what's going on. And what I want are frequency peaks. So I want that. And I open the help file, and then here it says zsa.easy. That sounds attractive. Frequency peaks, and it's got some numbers, and it's got this stuff here. So I know that I'm just going to copy that much of it. And I'm going to throw it into my file. For those that are curious, if you look inside here, there is a PFFT. So it kind of wraps up an FFT. And this uses the, so inside here is another patch that actually uses the ZSA frequency peak. But you don't have to know any of this to use it. You just say, all right, I believe that that works. It says there's a threshold and a number of peaks. Well, the number of peaks we're going to sort out here is 4. And what's going to happen here is we're going to put audio into this side. And what comes out here is going to be a list. And you can see there the list says Freak 1, Amp 1, Freak 2, Amp 2, Freak 3, Amp 3, Freak 4, Amp 4. Right, so we're going to get a list of that sort of stuff from whatever file we put in here. So let's choose a file. And I'm going to get this file here. Holding down the Alt key, I can make this file appear in several different ways. I'm going to create an SF play with that object. I could have just dragged it in and it would have worked fine for these purposes. All right, so now I'm going to put this here. And we need a toggle to turn it on. And just to see that it's working, let's just print out what comes out of here when I do this. So right now it's printing a whole bunch of 0 because there is no sound. And as I turn on the sound, we won't hear it because I don't have it hooked up. Well, I'll hook it up. Oh, and I'm just gonna sum these together, left and right. All right, and then no idea how loud this is gonna be. sure my audio is still set correctly. Yes. All right, well, here it comes, ready or not. And we see we get a bunch of different changing numbers now. What are the numbers? The numbers are, the lowest frequency it detected was 161 hertz, and it had an amplitude of basically 0, right? So we get these, well, it's still going, and these frequency bins, which have not changed because it didn't detect any new ones, have 0 amplitude, 0 amplitude, 0 amplitude, and 0 amplitude. Right? It just, that's how it's going. So what we want to do is, let's do it the easy way, and we'll just unpack frequency 1, amplitude 1, frequency 2, amplitude 2, frequency 3, amplitude 3, frequency 4, amplitude 4. There are other ways to do that. And now we can just even label these. So this is frequency 1. Amplitude 1. And we'll just stop right there for a second. Questions about what's going on with this object?
Man, I wish I would have had this object doing a envelope follower or vocoder. That would have been
Yeah.
pretty easy.
Yes.
Cool.
Okay, so here's frequency 1 and amp 1. It's just coming from this ZSA thing, which I'm just using. I know what it does, which is nice, which is it detects the strongest 4 frequencies in a signal, the 4 frequency peaks. And this threshold thing works backwards than you would think. So it will let through, this is a noise threshold. So how much noise are we letting through, right? If you put this at 0, then you will have a very, very, very tone-centered analysis. If you increase this number, then it'll let through more things that it may not consider to be pitches. And you'll get some more behavior here.
Like noise or?
So, to detect a pitch, it has to throw out some other information that's like, well, is that really pitch or is it noisy? And so this is a number you'll play with, basically, for this purpose. All right, so we're going to receive these things. So receiving the frequency, receiving the amplitude. And what do we want to do with these? Well, let's say that the amplitude, this is going to be for the sphere number 1 here. So the amplitude will make it go up and down, and the frequency will make it go left and right, let's say. So let's say that the frequencies, let's pretend that these frequencies go between 0 and 3,000. And what we're going to do is we're going to say, okay, we'll go from like -1 to -0.4. So as it receives this frequency, right, if the frequency is higher, it's going to go more to the right. If the frequency is lower, it's going to go more to the left. So we want to somehow change our positioning idea based on this. So we're going to pack this up, a couple floats, and this one's going to go here. And then for our amplitude, we assume these amplitudes are between 0 and 1. And we would like them to go from, let's say, -0.6 on the y-axis. And it can go all the way to the top if it gets to 1. So receive the amp, scale it, and then we pack that in as well. And so now, now that I've made this little machine, I'll just have it send freq amp x, y. All right, so do you understand why I did what I did? Okay. So I'm assuming that these frequencies coming in that will be detected will probably not go above 3,000. just guessing. I probably won't go to 0, but I said 0 for whatever reason. And I'm also getting the amplitude associated with them, and then I'm sending out those numbers in a list because I packed them up. And I'll receive those here at my first sphere's position, and I will just change the x and y based on that. So right now it's being sent out low numbers, and as I play this tune, right, it'll move up and down. Okay, and we would want to repeat this process for all of these spheres. So let's do that. I'm not saying there's not a more efficient way, but this is a very clear way. Sometimes brute force is the right answer. Okay. Bear with me while I type in numbers. One more again, number 4. There we go. And we'll hook these up. And now we just have to duplicate this little machine 4 times. Really, at this point, maybe it would be a good idea to, encapsulate this. And, well, I actually don't want to do that because I have to change so many things. So I'm going to just duplicate it. Receive frequency 2, receive amplitude 2, and here I need to change the left and right scaling of this one. So it's going to start at negative 0.33, and it can go all the way to, I don't know, how far did the other one go? It went 6, so it can go all the way to positive 0.33. And the amplitude remains the same. And here I'll send number 2. So now we receive the same information for the other sphere into the other position. There we go. So we don't actually need these anymore. And now we can test and make sure that this works. Might need to get a different file. Okay, so it seems to be jumping around and doing something different than the first. Need a fast forward button. Okay. And we'll just continue making these machines. So frequency 3, amplitude 3, 3, and now this one will start at 0.4, and it can go, oh, I think I've run out of room. I did this kind of badly. Oh well, figure it out. It can go to 0.7, and let's change this. So this can go, let's say this can go to 0. And then this one can go from 0.1 to 0.4. There we go. And finally, the fourth one. This one's going to go from 0.4 to 1. Sending out number 4. All right, so theoretically, and we could be able to take these things here and line them up with the position, and then all of these will work in a similar way, responding to 4 different frequency regions.
Dr. Thompson?
Yes.
You wouldn't also need to change the scale value in each of the machines?
I did here for the frequency, but for the amplitude, I'm not worried about it. They should just hop up and down. It does look pretty wonky right now because I didn't do these evenly because I didn't think about it very well. So I'm going to kick this one off a little bit further that way. A little bit more. That's better. I don't know. I should have really done a better job of spacing these equally, but I didn't. It's okay. All right, so there we go. And I can't really change the number of peaks now without changing this whole structure. This is a little brittle as far as scalability goes, but for now it's going to work for the goal. Let me bring in a different sound file. That one's, I'll try this one. There we go. Hook these things up and go left and right. Oh, nice. I mean, it looks a little bit like the amplitude scaling is off. You know, it's not really going up very high on the y-axis. And there's a few ways I could fix that. I could just change it in the scaling. So I could say, well, these things really aren't going up to 1. Try to change it here. I could have multiplied the audio signal going into these. A few different ways to do it. So let's see if that improves the... yeah, there we go. Kind of liked that little initial movement there. Okay, play them both at once. All right. Anyway. So now I notice that the movements aren't very smooth, which kind of bothers me a little bit. So there's a few different ways to smooth out movements. One way I like is to use the slide object, which says how much do I slide up and how much do I slide down. The problem with this object is that it constantly needs to get information for it to do that. Right, so what it does is it kind of is like a filter, but unless you continually give it the information, it never gets to its destination without giving it the information over and over and over again. So if I'm going to do that, I might as well use, you know, an audio version of it where the signal is always going to it. So just as a little insider tip, this is typically how I would do it. I would turn our number into a signal. So the number coming out right here, for example, I'm going to turn it into a signal. I'm going to filter it in this way. So it's going to kind of smooth out. And then after I'm done doing that, I will turn it back into an event at the draw rate. So this is a little machine that just smooths out stuff. So basically what I'm going to do is I'm going to put that in between here and here.
Could you smooth out the data coming directly out of the audio file?
Well, it's going into this Easy Freak thing.
Yeah.
So, I mean, I could filter the audio, but that's going to change the audio itself. And so this will get inaccurate readings. So what's coming out of here, right, is probably what I have to deal with. And I just have to smooth it coming out of here. And there's numerous ways to smooth it, but this is not an audio signal. So
within the object, there might be an audio signal.
So here in the PFFT, so I'm going into FFT land. And yeah, I just don't think I want to deal with it. I think I would rather just smooth out the data rather than trying to smooth out the source. But good point. Maybe there's a way to do that. All right, so I'm going to make, I'm going to turn this into a patcher, which I do by encapsulating, Command-Shift-E. And I'll call this data smoother. And I will give it, And I will give it an inlet and an outlet. Inlet. So that's what comes in here, and an outlet. That's what goes out of there. And now I can just insert that where it needs to go. You can do it.
Could you open up that hatch one more time? Sorry.
I can, just a second. So let me move that there, move that there. Right, so basically it's just using the slide object. So I turn the event number into an audio signal, which would not sound very good. It would sound like terrible. Maybe. I don't know. We could listen to it. I don't think we should. And then we would use this slide object, right? And I guess if I'm being clever, I could say, well, maybe I want to change this slide value, right? I probably should have done that. And then I just snapshot it back to an event. So really, most of this patch is turning it into an audio signal and turning it back into an event. And the reason I turn it into an audio signal again is because the slide object needs continuous data to really slide to the next thing. And so it's just easier to do that as an audio signal. Okay, which one was that? That was not this one. That was this one. So I will just kind of redo here. Take this one with the other input and put it in there. And then if I wanted to, I could change the amount of slide it's got. So the difference there is that it shouldn't be quite as jumpy. Should smooth out a little bit. It's really not going as far up on the y-axis as I want it to.
Is it smoothing too much?
Maybe so.
Or like the duration's too long?
So let's
Is it-
see.
It's
let's see.
converting the two numbers into one number. The data smoother. What's coming out is just.
Oh, thank you. There we go. So I actually needed this data smoother. I put it in the wrong place. Thank you. That's what's going on. Okay, so good point, Andrew. So Andrew pointed out an error there, that I ran a list into the data smoother and then never just pretended like that wasn't what I was doing, which is not a good idea. So we'd really need a data smoother for each one of these. Oh, Max. All right, so bear with me while I do that, and that's going to make my life a little bit better. So I got to get rid of this, pull this down there, do that. The data smoother here, shift there. Okay, so bear with me. Okay, because we haven't gotten to the fun part yet, although this is pretty interesting. We would rather it be more fun, and we're about to get there. So let me move this down.
Making all the
These.
infinite spheres behind it.
Yeah, right. We want to process this image because, you know, it's cool, but it's a little rudimentary. Okay, so a couple of those, a couple more of those. Oh, that goes there. That goes there. This is where you really pay the price for not being elegant in the first place, but it's okay. You make it work first, then you make it better. All right, so now, yeah, they jump up in the air a little bit. Still not as much as I want, but I'm just going to let it go. I could tweak this. All right, so that's the first part of the thing, right? Is that, okay, great, we've got spheres jumping up and down based on 4 frequency regions of an audio file. That's fantastic. And so now we've finished Tom DeFonte's part of things, and now we want to run this into Dan Sandin's image processor. So here's the world, and here's the draw, and I'm just going to kind of move this up here, and I'm going to send the world image out somewhere. Right, so there's the world image. And a good way to view an image is generally on a video plane. So I'm just going to shift all this down, pretend like it doesn't exist, and get a jit.gl.video plane in the Spring Mix. And so that's going to put a video plane in there somewhere. I'm going to make the color of this be, well, I don't know what color I'm going to make it. I'm just going to leave it. But what I am going to do is I'm going to take this, this image and I'm going to throw it into the video plane. And we can see that now the video plane is in the world displaying the world, which displays the video plane, which displays the world. And so we have a classic feedback loop. And we can kind of position this a little bit. So just like all the other things, let's leave it. Let's leave it. Well, let's leave it there. Well, we can move it. So we'll make the ability to move that on 3 different axes if we wanted to. But really, I just want to change the z-axis, I think. So I'll make a pack here with 3 floats, one for x, y, and z. But really, I'm just going to, let's use a PAK. Really, I'm just going to change the z. So why am I using PAK instead of pack here?
So it changes regardless which of the 3 you change?
That's right. So notice that all 3 inlets now are hot, whereas in a PACK, these 2 would be cold. So I can move this video plane around. There we go. I'll move it back. You can see that now it reflects backwards, so it's like a hall of mirrors. So I'll move it back there. I could, move it left and right, I suppose. So if I shifted this off, then it reflects back that way. But I don't really want to do that. Additionally, I could rotate this video plane. I prefer rotate XYZ. It's a little more intuitive for me. And let's say I want to rotate it just on the Z plane. So the Z plane is the one that runs through the screen. So if we rotate it around that axis, we could get a spiral, should be. So let's rotate the video plane. And, there, yeah. So then it goes back into the Hall of Mirrors. And then we could see what it looks like as we play this stuff. We'll play both of them together. And then we could let our imaginations run wild and say, well, what would happen if we took, some other element of the audio and changed the rotation here or whatnot. Or we could even say something like, well, maybe in the feedback loop here, maybe I want to transform this world image using a shader. So jit.gl.slab. And because it's a VL object, I like to put it into the render space, just as a habit. And we run the world image into here, and then out back to here again. And then we can load in one of the files associated here. So let's say, whoops, let's say fisheye. Right, and so that puts some effect on it. And we can look at what it looks like. It's really hard to see. And it actually looks different here than somewhere else. And I could look inside the fisheye, and I could see what are the different parameters I could change. So anything that says param name has these values that I could pass in. So let's say I'm going to change the lens radius. I don't really know what it does, but it says it's there. So m param stop param lens radius, I think it was some number, and I'll just make sure that was right. Nope, no underscore. There we go. And I could run that into my effect and just see what the effect is. That's kind of neat. Now, when I close this file and open it up again, I'm not totally convinced that this slab will have this file. And I tried to say, well, transform attributes to arguments. And on my other computer, this did not work. On this one, it did. So fantastic. If that does not work, then over here in the inspector for this slab object, it will tell you which file you have loaded, and you can copy and paste that into the file attribute here. Right. And then you can go crazy. You can just transform this video in all sorts of different fun ways. Let's say we wanted to use the TD Rota thingamajig. So there it is, and let me get rid of this file attribute now. Maybe it's called that. And then if we looked in here, we would see that it has all these different things we're familiar with, the zoom, the offset, the bound mode, and all that. So let's choose to have a param zoom. And let's choose to change the bound mode. Nice try. Bound mode to 4. And we know that that's going to have a certain kaleidoscope effect when we zoom out. So I'll load in that, and then we'll do one of these, and we can see our image sort of changing. And, you know, we could even, let's use our amplitude 1 to change the zoom for fun. So the bottom frequency, for some reason, is going to change this. I'll offset it by some amount. And we'll play the tune and see what happens here. It's so dark. Yeah, it's okay. I mean, maybe I want to brighten up this video playing a little bit somehow. So let's stop the music. And I could use some sort of slab to change the brightness, right? So I could just get another slab and throw it in there and change this file to not be that anymore. And maybe find the one I want. So files, and there's a multiply. This is the one I was trying to use before, which I thought was pretty cool. Brightness, brightness. And now I can double click this one, and I see that there's some control for image and alpha. I don't know what image means, an integer. Shader for modifying image brightness by interpolating an extrapolation. All right, I'll bite. I'll try to change the alpha. Param alpha $1. And that's going into this one. See if I can make it a little brighter. Oh, yeah, I can make it, yeah, changes it. And then, you know, the fun again here. And now I'm wanting to like change this, the scale of this video plane. And now I've wound up with something totally different.
Is there a
But-
way to hide the original spheres and just keep the new?
There is. It's a very good question, but it's complicated. So now I've got some fun stuff to play with, right? And I can mess around with this and kind of play compositionally. Well, I like that. All right. Anyway. So that is it. We made it all the way through that. Amazing. And I'll put up a cleaned up version of the patch onto the Google Drive and link you to it. What did we do? We figured out a different way to, or a little bit more involved way of using audio analysis to inform visual things. And we kind of did the play on let's generate a digital shape and render it in the world, and then get it out of that world and transform it using video processing, right? So that's a pretty powerful technique. Feedback is always a powerful technique. And so we did some of that.
Yeah, that video playing thing blew my mind. I did not.
Yeah.
I've never even thought about that before.
Yeah, that was cool.
There's a different one called jit.gl.layer, which does something actually quite similar. I think they're interchangeable. But yeah, I mean, having a video plane displayed in the world and the video plane is displaying the world, you know, it's classic feedback. You could do that with anything though, right? You could have a grid shape that is textured with like a sphere that's textured with the world, or a cylinder, and then display the world on the cylinder and the cylinder in the world, and then you get feedback effects like that. And there's a ton of different sort of video effects that you can put what I like to call in the feedback loop, or even not, you know. So the question of how would I not display that, or how would I, for instance, not have feedback, is that you would have to place cameras into the space, and the cameras would have to be, so a camera would have to be looking at the spheres, which should not see the video plane, and then the image of the spheres should be displayed on the video plane.
Could you just like call the spheres, like the initial spheres that you're seeing?
Basically, you have to use multiple cameras. That's what you
think-
have to do.
Well, you could also use like multiple videos or worlds too if you needed to. I
yeah,
think
if
that would
you-
be the simpler one. Is
I
that
feel
you
like
could-
this. Sorry, go ahead. Yeah.
Oh, you go ahead. You're good.
You just have to make sure that your world isn't displaying in the window you're looking at. I would say that probably the smart way to do it is to, if you're interested in this, then look at cameras and then look at the gl.node object. A camera can capture a space itself. Anyway, I think that's beyond the pale right now. It gets complicated. But so what I want you to take away from this is that you should probably get the package manager that is ZSA descriptors. And you should look at different ways in which audio can be analyzed, and then think of ways that you can quickly map one-to-one even those parameters to visual things. Because what ends up happening is initially that's a little bit too one-to-one, but then as you start becoming more complex, which is inevitable, and making things look really interesting, those sort of relationships get buried, but they're still there. So there's some sort of deep connection between the music and the image. And that's a nice place to be. For me, I'll have that, and then in addition, I'm going to have some physical controls, so that me as a human and as an artist can do what I want without having everything be algorithmic or generated by the sound. but to an extent to make those underlying connections with the sound is smart.
I have a question.
Yes.
When you're doing the feedback, does that do like crazy CPU stuff, or is it just because it?
No.
You've got infinite versions of that image. How does it
No,
handle
not
that?
really. It's not CPU intensive. You're actually getting it for pretty cheap. The only CPU intensive part is that we're getting the matrix back out of the world. So we've left the GPU and back to the CPU. But if you're using shaders after that, then there's only that one conversion. So we're having to jump out of the GPU to the CPU, and then we're right back into the GPU again.
And it's not intensive for the GPU either.
Feedback is not, no.
Okay.
It would be more intense. So the four spheres I created are more intensive than that whole feedback process. Definitely. So I'm going to put up onto the folio these tasks we talked about earlier. I'll have those be due in a week. So just sort of a checkup to make sure that we're not accelerating beyond the speed of light and leaving behind the fundamental concepts that are necessary to build anything like this. Okay, and with that, I will end the meeting and post. Wow, there's only 2 things in the chat, and post the video up to the Folio website and email it to you. I will also post Tuesday's video, which I have not done
Was
yet.
that Orazio Vagione that we were listening to? Points
No, that's
critique?
Bernard Parmigiani.
What?
Yes,
Oh,
Yeah,
I
question.
knew I recognized
from
it.
the 70s.
I do have a question before we go.
Yes.
Can the objects physically, is there a package or something that an object can affect another object? So if 2 circles are going into each other, can one like push one into each? I don't know. Like, can one like elope around it?
Physics.
Physics. Is there a physics engine?
Well, yeah. So, yes, there is. We'll get to that. And also, objects could, for example, we could have the grid shape output a matrix, so all the vertices of the sphere, and we could fade that into a noise object, for instance. So then noisy sphere, or we could morph a sphere with a cube. So objects can combine in that way, where we're basically just taking the vertices and interpolating between 2 places, or doing whatever we want. And then to answer your other question about can objects know something about the other object, there's a physics engine in Max that we'll get to.
Yeah. Yes.
Sick. All right.
All right. So, okay. See you guys later.
Bye.
Bye. Thank you.
Bye.